Dear students, I am Dr. Rajeev Sapre. This is lecture number 17 about the topic topology of metric spaces. See, in the previous lecture, we have defined what is open sphere in a metric space. In short, what is it? Suppose you have a metric space x comma d, okay, and suppose x0 is any point belonging to x, r greater than 0, positive real number. Then we have defined what is Sx0R, right? What is this? Open sphere with x0 center, r radius. What was the definition? It is the set of all x belonging to r such that distance between x and x0 is less than r. And we have seen one or two examples. That means when you take r comma d, where d is a usual distance, when you say it is a usual distance, that means d of x comma y is same as mod of x minus y. And in this case we have seen that open sphere is an open interval. It means what? So here we have seen that if you want to have Sx0R, okay, this will be open interval x0 minus r to x0 plus r. This is what we have seen. Also, whenever you take r2, r2 is what? Two-dimensional coordinate system, and d, usual distance when you take. That means there d of x comma y is equal to root of x1 minus y1 bracket squared plus x2 minus y2 bracket squared, right? Where here we have considered x as x1 comma x2. Now this is the convention. X is taken as x1 x2, y is taken as y1 comma y2. So it becomes simple. Then in this case, S, suppose you have center is suppose P comma R, and suppose P is where we can say P is the point having coordinates P1 comma P2. Then in this case, what is SPR? It is the interior of the circle with center at P, radius R. So if the coordinates of the center are P1, P2 and radius is R, we know from the what we can say conic sections that we have studied, the equation of that circle will be x minus P1 bracket squared plus y minus P2 bracket squared is equal to r squared, right? X and y are those points where this condition is satisfied. हे सर्कल झालं आणि याच्या आतले सर्व पॉइंट्स, interior of this circle. So diagram can make the ideas clear. See, suppose this is the circle, right? Here the center of the circle will be P1 comma P2, this point P1 comma P2, and radius is R. So all the points inside this circle is the open sphere SPR, right? But you know that these are not the only two metrics. On R2 itself we can define, and you know we have defined metrics on lots of sets, sequences, set of sequences, set of continuous functions. Discrete metric space is also there. So what will be the nature of open spheres? How the open sphere will look like? That we will try to work in this lecture. So we begin with the metric. Okay, I will erase all this. We will begin with the metric on R2. Okay, so we will have this definition. Say R2 is the underlying set. So I will take X as R2. See, generally it is a process to take X as the underlying set. And what is X that you tell? So here X is R2. Okay, R2 when you take, you know the elements of R2 are the ordered pairs. Elements of R2 means what? They are ordered pairs x comma y, where x and y both belong to R. Okay, now what we have to do is we will take a metric, say d1 x comma y will be here. Now always whenever you take x and y, means here this x and this y, so we will define d1 x comma y is equal to sum of x1 minus y1, right, plus mod of x1 minus y1 plus mod of x2 minus y2, where x is equal to x1 comma x2 and x1 comma x2 and y is y1 comma y2. म्हणजे इथे मेट्रिक आपण कसा डिफाइन केलाय, डिफरन्स बिटवीन एक्स कोऑर्डिनेट्स, ते जे काही दोन पॉइंट्स आहेत ज्यातलं डिस्टन्स तुम्ही काढता आहात, तर डिफरन्स बिटवीन एक्स कोऑर्डिनेट्स मॉड ऑफ दॅट प्लस डिफरन्स बिटवीन वाय कोऑर्डिनेट्स मॉड ऑफ दॅट. You have already proved that this is a metric, so we will not do it again, right? This is a metric, this is well known. Now I have to calculate open sphere with center at say P. So what is SPR? Here this is what we are interested. SPR किंवा आपण असं करूया, instead of P we will take origin, that will be better, and radius we will take 1 particular case we will take, but then from that we can generalize, right? So I hope you will do that in after this is done. So what we will do is we will see, or we will draw the figure how the open sphere looks like with center at 0, origin means center at 0 0 and radius 1 in case of this metric. So इथे आपण असं लिहूया पाहिजे तर SD1 म्हणजे open sphere with respect to D1. Whenever it is a usual metric we need not write. But here now particularly we are not, you are actually working with some different metric other than usual metric. So it is better to mention, right? If you are not mentioning it is nothing wrong, कारण आपण आता हा प्रॉब्लेम सोडवतोय, so we are using this metric. पण एक परफेक्टनेस येण्यासाठी तुम्ही D1 लिहू शकता. Now what is this? This is equal to the set of points x comma y belonging to R2 such that distance between x comma y and 0 comma 0 distance, now this distance can be d1, must be d1, right, less than 1. Okay, now what is the formula for this? So it is what, now we can say xy d1 x comma y कॉमा 0 कॉमा 0. आता इथे फॉर्म्युला काय बघा, ज्यावेळी x म्हणजे x1 x2 y म्हणजे y1 y2, त्यावेळी त्यातलं डिस्टन्स आपण कसं काढलंय, d1 डिस्टन्स मॉड ऑफ x1 मायनस y1, तसं इथे होईल मॉड ऑफ x मायनस 0, राईट. सो दिस इज ऑल x कॉमा y बिलॉंगिंग टू R2, ओके, सच दॅट मॉड ऑफ x मायनस 0 प्लस मॉड ऑफ y मायनस 0 इज लेस दॅन 1. ओके, म्हणजेच याचा अर्थ काय झाला, इट इज सेट ऑफ पॉइंट्स x कॉमा y बिलॉंगिंग टू R2, राइट, and mod x plus mod y is less than 1, right. Now mod x, so whenever I want to draw this particular region, what I will do is I will consider first as mod x plus mod y equal to 1, आणि त्याच्याहून लहान आहेत म्हणजे inner part we will take. Okay, so same thing that is done in case of real number set also, same thing is done. We are first, we assume that that is equal, and what will happen. So if I want to draw figure, what I will do is consider, so this is suppose 1, right. Now consider mod x plus mod y equal to 1, right. Draw the boundaries. Boundaries will be this, and less than 1 means inside part of that. If it is a closed figure, we'll see what is the figure. Now here you know by absolute value formula that mod x is either equal to x or minus x. Similarly mod y is equal to y or minus y. So from this equation 4 equations emerge. One of them will be, see, whenever mod x is equal to x, mod y is equal to y, you get x plus y equal to 1. When mod x is equal to minus x and mod y is equal to y, you get minus x plus y is equal to 1. That means what? X minus y is equal to minus 1. Right? This is when mod x is equal to minus x. Third possibility is mod x is equal to x. So I write these possibilities here. When mod x is equal to minus x and mod y is equal to y. This equation. Right? Now when other way around. Now when mod x is equal to x, right, but mod y is equal to minus y. In this case what will be this equation? Mod x plus mod y 1 आहे ना आपलं इक्वेशन. मग त्याच्यामध्ये mod x म्हणजे x घेताय तुम्ही. x minus y is equal to 1 असं येईल, कारण mod y minus y. आणि फायनल केस काय होईल की mod x is equal to minus x आणि mod y is also minus y. So in this case your equation becomes minus x minus y is equal to 1. That means what? X plus y is equal to minus 1. So now you have to draw these 4 lines. These 4 lines will be the boundary of that open sphere, right? And then inside part, interior part of this closed figure will be the actual open sphere. Now these are straight lines. See, x plus y is equal to 1 ही जी स्ट्रेट लाईन आहे, आपण जर x आणि y ॲक्सिस काढले तर साधारणपणाने ते असं असणार आहे. सपोज दिस इज युअर y ॲक्सिस and okay, I will make it straight, and suppose this is your x axis. Okay, now this we are interested in 1 only, so here I can take this here straight away. Now here it will be say 1 comma 0. Here it will be on this side minus 1 comma 0. Here it will be 0 comma 1, and here it will be 0 comma minus 1. Now x plus y is equal to 1. Whenever I take this line, what is its x intercept? आपण कुठल्याही स्ट्रेट लाईनचा x इंटरसेप्ट कसा काढतो? y0 ठेवतो त्याच्यामध्ये. y इंटरसेप्ट कसा काढतो? त्या इक्वेशनमध्ये x0 ठेवा. म्हणजे 1 आणि 1 येणार, म्हणजे एक्स ॲक्सिसवर 1 आणि वाय ॲक्सिसवर 1. म्हणजे ही स्ट्रेट लाईन जी आहे ती कशी असणार आहे? तर इट विल बी लाईक दिस. ओके, त्याच्यानंतर हे बघा आता x मायनस 1 इज इक्वल टू मायनस 1, एक्स मायनस वाय इज इक्वल टू मायनस 1. इथे एक्स इंटरसेप्ट किती असणार? तर y0 ठेवा तुम्ही, म्हणजे x इज इक्वल टू मायनस 1 येईल, म्हणजे इथे, आणि म्हणजे हा पॉईंट. आणि y इंटरसेप्ट ह्याचा किती असणार? x0 ठेवा, म्हणजे y इज इक्वल टू 1 येईल. बघा इथे मायनस वाय इज इक्वल टू मायनस 1, म्हणजेच y इज इक्वल टू 1. त्यामुळे ही स्ट्रेट लाईन असेल ती फ्रॉम धिस टू धिस. ओके, त्याच्यानंतर तिसरी लाईन बघा, x मायनस वाय इज इक्वल टू 1. इथे x इंटरसेप्ट किती असणार? y0 ठेवा, म्हणजे 1. y इंटरसेप्ट किती असणार? x0 ठेवा, मायनस 1, म्हणजे मायनस 1 टू 1, म्हणजे ही अशी लाईन येणार. आणि शेवटचं काय बघा, x प्लस वाय इज मायनस 1. इथे x इंटरसेप्ट म्हणून मायनस 1, y इंटरसेप्ट म्हणून मायनस 1, म्हणजे ही लाईन अशी येणार. राईट, तेव्हा हा काईट टाईप एक फिगर झाली विच इज अ क्लोज्ड फिगर, अँड ऑल द पॉइंट्स इनसाइड दिस रिजन इज दिस ओपन स्फियर. Right, so I hope you understood. Instead of now origin, you can take any point. Try this as an exercise. Suppose I take point P1 comma P2, and if you take radius R, what will be the nature of this open sphere? So that I leave it as an exercise. So draw S P1 comma P2 and radius R. इथे आपण particularly P1, P2 we took as origin and radius we took as 1. But always in general, whenever you want to see what will be the nature of this, or what will be the geometrical representation of this particular open sphere, you can think of this also. So try to draw this figure, and portion inside that closed region will be the open sphere. Okay, now we will come to the third exercise, this third type of metric that we have defined. I will erase all this. Okay, all this I will erase. I hope you understood this and you can work on such problems. That problem is given to you. Okay, so now instead of that d1, now we will take say d2, right? D2, second metric we will take, that we have already defined on that R2, right? But the definition was different. Instead of plus, it was maximum, right? So now again same, and you know what are the elements in that, etc. So now you define D2. D2 x comma y is, you know, maximum of mod of x1 minus y1 comma mod of x2 minus y2. Okay, where, you know, x is always taken as x1 comma x2 and y is taken as y1 comma y2. Okay, now what? Now you will again, this is a metric we have already proved. So now we are interested in what is SD2 of say origin, means center will be at say origin and radius 1. Again same problem we will continue, but same center and radius we will continue. So now this is the set of elements in R2, x comma y belonging to R2, such that this condition is satisfied. That means what? Maximum of what? X1 minus y1. Now here x1 is 0 0, means this center is 0 0. We are interested in what? Maximum of what? आपल्याला काय करायचंय बघा, x comma y belonging to R2 की आधी आपण हे लिहूया, that will be better. So instead of this we will write d2, correct? d2 distance, second d2, we have to prove that we have to consider those points where d2 x comma y comma 0 comma 0, this is less than 1, right? So it is set of points x comma y belonging to R2 such that now it is maximum of what? See, difference between x coordinates, हे x1 आणि y1 x coordinates आहेत, तसं इथे maximum of what? Mod of x minus 0 म्हणजेच mod x comma mod y, हे तुम्हाला लेस दॅन 1 पाहिजे. ठीक आहे. मग आता मॅक्झिमम ऑफ मॉड ऑफ एक्स मॉड ऑफ वाय, वी कॅनॉट से व्हॉट इज, इफ यू डू नॉट नो व्हॉट इज एक्स अँड व्हॉट इज वाय, यू कॅनॉट टेल व्हॉट इज मॉड एक्स मायनस मॉड वाय. सो देर विल बी 4 पॉसिबल केसेस. समजा मॉड एक्स हे मॅक्झिमम असेल या दोघांमधलं, तर मॉड एक्स लेस दॅन 1 येईल. मॉड वाय मॅक्झिमम असेल तर ते लेस दॅन 1 येईल, किंवा दोन्ही समजा इक्वल असतील तर ते कॉमन व्हॅल्यू मॉड एक्स किंवा मॉड वाय, मग तिथे काही घ्या तुम्ही, लेस दॅन 1 येईल. म्हणजेच मला काय काय केसेस कन्सिडर करायला पाहिजेत, दॅट इज, म्हणजे मला मॉड एक्स पॉसिबली मॉड एक्स कॅन बी मॅक्झिमम, राईट? सो मॉड एक्स लेस दॅन 1 ऑर मॉड वाय लेस दॅन 1, राईट? बिकॉज आय डू नॉट नो विच इज मॅक्सिमम. सो दीज आर द 2 केसेस, हे मॅक्झिमम असेल किंवा हे मॅक्झिमम असेल. मग आता मॉड एक्स लेस दॅन 1चा अर्थ काय? मॉड एक्सच्या व्हॅल्यूज कशा असतात, एकतर ते एक्स असतील किंवा मायनस एक्स असेल. सो वी हॅव 2 केसेस हिअर. दिस इम्प्लाइज एक्स इज लेस दॅन 1 ऑर मायनस एक्स इज लेस दॅन 1. इथे काय होईल? सेम स्टोरी हिअर. मॉड वाय लेस दॅन 1 म्हणजेच एकतर वाय लेस दॅन 1 ऑर मायनस वाय लेस दॅन 1. कारण तुम्हाला हे माहिती पाहिजे मॉड एक्सची व्हॅल्यू काय असते. बघा हा फॉर्म्युला आहे, पुन्हा एकदा मी रिपीट करतो. मॉड ऑफ एक्स इज इक्वल टू एक्स वेन एक्स इज ग्रेटर दॅन ऑर इक्वल टू 0. इट इज इक्वल टू मायनस एक्स वेन एक्स लेस दॅन 0. सो दॅट वी आर युझिंग हिअर. मग आता काय करायचं आपण? लेस दॅनचं म्हणजे इनइक्वॅलिटी जी आहे ती इक्वॅलिटीमध्ये कन्सिडर करायची. म्हणजे आपण हा जो काही ओपन स्क्वेअर होईल, व्हॉट विल बी द बाउंड्रीज ऑफ दॅट? एक्स इज इक्वल टू 1, देन मायनस एक्स इज इक्वल टू 1, नंतर इकडे वाय इज इक्वल टू 1 आणि मग मायनस वाय इज इक्वल टू 1. पण मायनस एक्स इज इक्वल टू 1 इम्प्लाइज व्हॉट? एक्स इज इक्वल टू मायनस 1 आणि दिस विल इम्प्लाय वाय इज इक्वल टू मायनस 1. मग ह्या स्ट्रेट लाईन्स आहेत. सी, एक्स इज इक्वल टू 1 इज अ लाईन पॅरलल टू वाय ॲक्सिस. हे तुम्ही 10वी 9वी मध्येच मॅथमॅटिक्सला शिकलेला की एनी एक्स इज इक्वल टू कॉन्स्टंट इज अ लाईन पॅरलल टू वाय ॲक्सिस. and y is equal to constant is the line parallel to x axis. त्यामुळे इथे मला फिगर कशी काढता येईल बघा याची, की हे तुम्ही समजा हा y ॲक्सिस घेतलात. सपोज दिस इज युअर x ॲक्सिस. ओके, नाउ आय टेक से हियर 1, हियर इट इज 1, सो दिस इज 1, दिस इज 1, दिस इज से -1 आणि इकडे हे -1. आता x is equal to 1 is a line parallel to y axis, right? So it will be like this, parallel to y axis. हा तुमचा आपण इथे नावं देऊया, नाहीतर त्या दोन पॅरलल लाईन्स सर्व दिसतील, म्हणजे मग कुठला x ॲक्सिस आणि त्याला पॅरलल लाईन कुठली हे नाही लक्षात येणार लोकांच्या. x इथे y. Now it is okay. We want to draw a line parallel to y axis passing through this point. So it should be like this. Okay, this is 1 suppose. Okay, I will erase this. ठीक है. Now this is the line parallel to y axis at a distance 1. Now here I have to draw a line. See, now this is x is equal to -1. That means on this side. It is a line on this side passing through that -1. Right? So this equation of this line is what? It is x is equal to 1. This is x is equal to -1. Similarly, here it will be y is equal to 1. Line parallel to x axis and above x axis. This is that line. Y is equal to 1. Okay, and this is y is equal to -1 passing through this point. So equation of this line is y is equal to 1 parallel to x axis at a distance 1 above x axis plus 1, and y is equal to -1. It is the line here. So you got this square की ज्याची साइड आहे 2, बरोबर ना. हे डिस्टन्स 1 आहे, हे डिस्टन्स 1 आहे, सो साइड इज 2. हा जो इनसाइड पार्ट आहे त्या स्क्वेअरचा, दॅट इज द रिक्वायर्ड ओपन स्क्वेअर. So I have analyzed it. Now exercise for you is draw SD2, P1, P2 and radius R. How this open sphere will look like geometrically. Try to do that. So this is open sphere. याच्यामधून काय आपल्याला कळलं बघा, तीनही ठिकाणी म्हणजे युज्युअल डिस्टन्स होतं त्यावेळी S00, 1 was a circle with center at origin radius 1. When it was D1, it was a kite type figure, same center, same radius. And here also in D2, same center and same radius we have taken 0, 0 and 1. What we got? Different. It is a square. It was kite in case of D1. It was circle in case of usual distance. So what it means is nature of the open sphere changes, right? Set changes, that set, but then they are all open sphere, because see, from this what we learn is this, that everything depends on the metric, not only metric, underlying set also. हा मेसेज या लेक्चर मधून आपल्याला मिळाला की आपण जर मेट्रिक बदलला, सेट तोच ठेवला आपण बघा R2, सेम underlying set was R2, but we changed metric, open sphere changes. Okay, so I hope you understood this message from this lecture, and 2 exercises I have given. Try those exercises, draw those figures. Idea you will get from whatever we have solved here. ठीक है, we will stop here. We will continue in the next lecture. Thank you.